Hi students, so we'll be solving NEET level MCQs for the chapter current electricity. Okay, so see, the question number starts from up to question number uh, 14 we have done. Okay, that contains capacitors. From 15 current electricity starts. So let us see question number 15. Okay, in the material it is question number 15. So it says the current through a wire depends on time as follows. I equals to I naught plus alpha t. Now here alpha and I naught are constants. So I naught is given 10 amperes and alpha is given 4 amperes per second. Why it is given 4 amperes per second? Why the unit is ampere per second? Simple. This is current, so this must be current, and this also should be current, right? From units and dimension chapter you know that current can be added with current. When two quantities are added, they should have same dimension and unit. So since this is time, but you want this to be ampere, so this must be ampere per second. Okay, so what they want now is the amount of charge which passes through a section of the wire in 10 seconds. So they want you to find the charge in 10 seconds. Now first you have to understand that this current is not a constant current. It is not a steady current. So you cannot write Q by T. You have to write, since it is instantaneous current, how should we write? You know that we can write it as dQ by dt. Okay, then since current is given and you have to find charge, what I should do? Integrate, cross multiply. So first cross multiply and then integrate. First cross multiply and then integrate. So this will be the total charge, and here current is given how much? 10. This is your 10, no? 10 plus 4t, because I naught is 10, alpha is 4. So current is 10 plus 4t dt. From where to where? From 0 time to 10 seconds. Right? The variable is time, so units should belong to time. So here you can see you have to do two terms integration. So first you should integrate 10 dt. So total charge will be integral of 10 dt. 10 is constant, you can take outside. 0 to 10 plus 4 is constant, you can take outside. Integration of t dt. Right? Second term is 4t dt from 0 to 10 seconds. So this will be integration of dt is what? T. Upper limit 10, lower limit 0. Integration of t dt is t square by 2. Formulas you should know. For integration and differentiation, formulas you must remember. So integral of x dx is x square by 2. So t dt will be t square by 2. Then you put upper limits and lower limits. So if you put upper limit and lower limit, what will be the answer? This will be 10, put upper limit 10 minus 0, 4 into, put upper limit 10 square by 2 minus 0 square by 2. 0 square by 2 is 0 only. So this will give you 100, and here this will be 100 by 2, 50. 50 into 4, 200. So total charge flowing is 300 coulomb. So which option will be the right answer? Option C. Okay. Let us go for the next question now. Question number 2. Please make note of everything. Now in exam, the current function may be anything. They may change the current. Here current was given. What was the function? I naught plus alpha t, and I naught was 10. Alpha was 4. 10 plus 4t. They may give you in exam I equals to maybe just 4t only. So then you can easily integrate, right? Okay. See question number 16. An electron moves in a circle of radius r with a constant speed. Find the electric current at a point on the circle. So there is a electron, single electron, which is moving in a circle. Okay, so don't think this is some wire. It is not a wire. Electron is simply moving in a circle. So like you can think of electron moving in atoms. So they move in the circle. But this is not any wire, right? Okay. So the radius is r, speed is v. Now, since this is electron, it has a charge, right? And since it is moving, it must constitute current. Current is what? Moving charge. So if you want current, what you do is you take some point here. Take any point, P. Now, in time capital T, what is capital T? Time period, which is time taken for one revolution. So in one time period, check how much charge will pass through this point. How much charge passed? One electron, yes or no? See, this electron, when it comes back here, when electron comes back here, that will be called time period, time taken for one revolution. So as the electron completes one revolution, through any point, only one electron is passing. So current will be the amount of charge which is passing, which is E, divided by the time taken. And time taken here is time period. If you wait for two time period, 1, 2. So how much charge passed? 2 times electron passed. So you have to write 2E. So again 2 will cancel. Same thing you will get. Same thing you will get, right? So this is the current. Now in some question they will give you frequency of revolution. Then what will you do? 1 by time period is frequency. So just multiply the charge of electron with frequency of revolution. You will get the current equivalent to this electron which is moving in a circle. But here they have given you radius and speed. So what will be time taken for one revolution? Distance covered in one revolution is 2 pi r, speed is v. So it will be 2 pi r divided by v. So this is the current in terms of given quantities. So which will be the right answer? EV by 2 pi r, option A. So quite a simple question, right? Okay. Let us see question number 17 now. So in question number 17, they are saying a current of 2 ampere exists in a wire of cross-sectional area 1 millimeter square. Area is 1 millimeter square. Find the if each cubic meter matlab per meter cube, the wire contains 6 into 10 to the power 28 electrons, free electrons. So this is number of electrons in 1 meter cube. Matlab what it is? Number density. Then find the drift speed, drift velocity. So we know the formula for current in terms of drift velocity. So NA drift velocity into E. So drift velocity will be what? Current divided by NAE. Correct now? So what is the current in the question? Current in the question is 2 ampere. Number density is 6 into 10 to the power 28. Area of cross section is 1 millimeter square. So area is 1 millimeter square. If you convert in meter, it will be 10 to the power minus 6. Because 1 millimeter is 10 to the power minus 3 meter. Square is there, so it will become 10 to the power minus 6. So area is 10 power minus 6. Charge of electron I can write 1.6 into 10 power minus 19. Okay. So then you have to simplify this. So this will be 2 divided by 6, 6 are 36, 6 3 carry, 6 1 is 6, 9.6. So 2 divided by 9.6 into 10 to the power how much? 28. See, minus 6 minus 19 will be minus 25. Minus 25. 28 minus 25 will be plus 3 in the denominator. When it comes in numerator, 10 to the power minus 3 meter per second. Now roughly you can take this as roughly 10. So 2 by 10 I can write 0.2. So approximately 0.2 millimeter per second. Approximately. So check which is the closest answer. So here they want the answer in terms of 10 to the power minus 4. So this is 0.2 into 10 to the power minus 3, right? Which I can write 2 into 10 to the power minus 4. 2 into 10 to the power minus 4. So closest option is option B. Option B. So let us see question number 18 now. So in 18 they are saying a parallel plate capacitor has plate area 10 centimeters square. So imagine this is your parallel plate capacitor. Okay, so the plate area is given 10 centimeters square. Separated by distance is dV right now, that is equal to 1 millimeter. Now it is filled with dielectric mica and connected to a 6-volt supply. So this space is filled with some medium, and that medium they are calling it as mica. Dielectric medium it is. And they are connecting here 6-volt battery. 6-volt battery. They are asking find the leakage current through the capacitor. If resistivity of mica, resistivity we write rho, is 10 to the power 13, unit is ohm meter. Why unit is ohm meter? We know R is what? Rho L by A. Correct na? So what will be resistivity from here? R A by L. So what will be the unit? So this can be asked for 1 mark in board exam. So what is the unit of resistivity? Resistance is ohm. Area will be meter square. Length is meter. Meter cancel. So it will be ohm meter. Okay, ohm meter. So please remember this unit of resistivity. Now in this question, they have given you the resistivity of this mica. Now it is quite a large number you can see. So now they are asking what is the leakage current. Now usually if you remember in capacitor we say once the capacitor is charged, then we say there is no current through the capacitor. Why? Because we consider this medium to be a perfect insulator. But students, in real life nothing is perfect insulator or perfect conductor. So this material has very high resistivity. It will be a very good insulator. That is why the charge will be stored in the capacitor. The charge will not flow. However, practically every medium will have some resistivity. Therefore, some current will go. Nothing will have infinite resistivity. Of course, for theory, in some approximations we can assume, no doubt. But since in this problem resistivity is given as a number, we have to calculate the current. We cannot simply say there will be no current like that. So how to find the current? Let us find the resistance of this block. So resistance formula is what? Rho L by A. Since current is flowing like this is the area and this is the L. So your L will be D in this problem. I hope you remember, right? For a wire like this, we write this as L and this as area. So for this material, this will be area and this will be L. Okay? It's fine. So let us calculate the resistance first. What is the resistivity? 10 to the power 13. Very large number. Length is 1 millimeter. So 10 to the power minus 3. Area is 10 centimeter square. Matlab 10 into 10 to the power minus 4 meter square. 1 centimeter is 10 to the power minus 2 meter. So this will be 10 to the power minus 3, right? So area is 10 to the power minus 3. These two will cancel. So this will be the resistance. Huge resistance. So what will be current flowing through this material? Voltage is given. So write Ohm's law. V by R. So 6 divided by 10 to the power 13. So 6 into 10 power minus 13 ampere. It is such a small current, students, that for practical purposes you can assume this is almost zero. So that's why in the case of capacitor we assume no charge flows. Matlab the whole charge is stored on the capacitor once the capacitor is fully charged. Okay, so answer is 6 into 10 power minus 13, option C. Let us now see question number 19. So in 19 we have to find equivalent resistivity. You know how to find equivalent resistance, right? In series and parallel. Here we have to find equivalent resistivity. So let us see how to do. Two wires of equal diameter of resistivities rho 1 and rho 2 and lengths are not same, L1 and L2 are joined in series. Parallel you try. What is the equivalent resistivity of the combination? So two wires are there, equal area. So areas are equal and they are connected in series like this. Okay, so this has resistivity rho 1, this has resistivity rho 2, this length is L1, this length is L2, area is same. Area for both of them are same. Now you know that this can be replaced by a single resistor or single wire, right? So that we have to find resistivity of that single wire. That will be called equivalent resistivity. So whatever is the resistivity of this, let us write rho equivalent or effective resistivity. Okay, but be careful, the area will be A, but length will be how much for this wire? How much it will be, L1 or L2? No, it will be L1 plus L2, because you have to replace these two by one wire, no, here. So the length will be L1 plus L2. Okay, so now you know that if this has resistance R1, this has resistance R2, and this will have resistance R effective. Since it is series combination, what formula will you write? R effective is R1 plus R2. So what will be R1? Rho 1 L1 by A. Here rho 2 L2 by A. And for this, what will you write? Rho effective length is L1 plus L2 divided by area is same, right? So A. So area you can take common here and cancel. So rho effective will be rho 1 L1 plus rho 2 L2 by L1 plus L2. What will happen if they say these two wires have same dimension? Then L1 L2 also will be same. So this will be L1 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 plus L1. So this will be 2L1. Then L1 will cancel. You will get rho 1 plus rho 2 divided by 2. Okay, if the length were equal. Fine. So let us now see the next question. Please pause the video and write down everything neatly. All these questions are very interesting, good questions, and they are not so difficult also. See question number 20 now. They are saying the resistance of a wire at temperature T degrees Celsius is given by formula R equals to R naught 1 plus AT plus BT square. So this is the resistance at what temperature? T temperature. So T is not time here. T is temperature. So in physics, no, there are many concepts and alphabets are less in number. So sometimes same concepts will different concepts will have same symbol. So you have to be careful while reading the question. So this T is temperature. Now what is R naught? R naught, they are saying, is resistance at 0 degrees Celsius. Obviously, if you put 0 degrees Celsius 0 0, what will be your resistance? R naught into 1. R naught. So R naught is nothing but resistance at T equal to 0. Now they want temperature coefficient of resistance. Alpha they want at temperature T. So this is a good question because in real life this is how the resistance varies. It is not a linear function, it is a quadratic function. Understood or not? So alpha will no longer be a constant, it will depend on temperature. When we consider the variation of resistance to be linear, that time we take alpha to be constant. But in this example, you will see yourself now that alpha will be a function of temperature. You have to find the formula for alpha. Now let us go back and think how we introduced alpha. We wrote alpha like this. We wrote R2 minus R1 equals to alpha R1 T2 minus T1. Remember this formula, right? This is also approximate formula. So now this is true only when I consider alpha as constant. But alpha, if alpha itself is changing, then what I should do? I should write this formula for small changes. For small changes. So for small changes, I can write this as dr. Change in resistance. So this is, so I can write dr. Dr matlab small change in resistance. Alpha. Here I will write R. R is the original resistance, dr is the change. In T2 minus T1, what will I write? Dt. Here I will write small letter because T is used for small letter is used for temperature. So this is actually change in temperature. Just you write for small change, you write dt. So from here what will be alpha? dr by r dt. So what I should simply do to calculate alpha is calculate this ratio. So 1 by r into dr by dt. But small t, okay, because temperature here they are writing small t. So now you know how to take differentiation of any function. So what is differentiation of this function? R naught will come outside. Differentiation of 1 will be 0. Differentiation of at will be a. Differentiation of bt square will be b into 2t. So 2bt. Right? You know this differentiation, right? Differentiation of x square is 2x. So differentiation of t square with respect to t will be 2t. So this will be r naught a plus 2bt divided by r. And what was your r? R naught 1 plus at plus bt square. This is your r, no? At temperature T. So r naught cancels. So this is the ratio which they want. So what is the answer? A plus 2bt 1 plus at plus bt square. Option A. Okay, fine. Let us see question number 21. So in 21, you have to know when you write the resistance of a conductor as rho L by A. Rho L by A. L is the length of the conductor which should be measured parallel to the current. And A is the area which is perpendicular to the current, right? So here you see question number 21. This question has come in JE also, but it is very simple. So I have included it in NEET exams. So look at NEET section. Consider a thin square sheet. In the diagram, they have given you a thin square sheet like this, whose side is L. So this is L, this is L, right? Square they told. Thickness is T. Thickness is T. And the material has resistivity rho. They want resistance between two opposite faces shown by the shaded area. So shaded area. So they have shown this part shaded and this part shaded. Okay. So they want resistance between this terminal and that terminal. So if you want resistance between those two, then you have to imagine a battery here. So current will flow like this. Current will flow like this if you put battery. So what will be resistance R? Rho L by A. This is how we write. Now L should be measured along the current. So if you want between these two, current will flow this way. So the length will be this length, which is how much? L. And area will be this area. So this area you can directly, what is this area? This side is L, this side is T. So area is L into T. It's a rectangle, no? Rectangle. So area will be L into T. So rho by T. So you can see the resistance between these two will not depend on the length. So let us see which option they have given. What is the answer? Directly proportional to L. No, it doesn't depend on L. Directly proportional to T. No, it is inversely proportional to T. Independent of L. That is correct. So option C is correct because there is no capital L. It will cancel now. So resistance will not depend on length of this length. So option C because it got cancelled. Okay students, and that is because I asked between these two. You try between these two, you try between these two also and see what answer you will get. Okay. So this is question number 21. Now let us see question number 22. So question number 22 is saying across a metallic conductor of non-uniform area of cross section, a constant potential difference is applied. The quantity which remain constant, already you know current will remain constant. We have done this in our entrance corner in while discussing the theory part. So option B. Question number 23 you see. A wire of resistance 4 ohm is stretched to twice its original length. What will be the resistance of the stretched wire? So there is a wire whose resistance is how much? 4 ohm. Now they are stretching it. When you stretch, it will become longer like this. So this is L, This is 2L, they are saying 2L. So area will become half. I have told you volume should be constant. So volume of a cylindrical wire will be what? Area into length. So since this should be constant during stretching, they can compress also. If you compress, length will become shorter, area will become larger. So constant during stretching. Okay. So now if you calculate the resistance of this, it will be rho L by A, which is given 4 ohm. Resistance of this new wire will be what? Rho will be same, material is same, length is 2L and area is A by 2. So new resistance will be 2 square R. So this is a very common result. So please try to remember, during stretching, if length increases n times, resistance will increase n square times. Okay, so answer will be 4 into R. What was your original resistance? 4. So answer will be 16 ohm. Now look here. Sometimes they will say length is not increased. They will say area has become 1 n times. Area has decreased n times. Same thing. If area has decreased n times during stretching, then length will increase n times. Right? And if length increases n times, resistance will be n square R. Sometimes they will not talk about area, they will talk about radius of the wire. So let me explain that also. So let us say you have a wire like this. Radius is small r. Okay, don't confuse with capital R. Capital R we are using for resistance. So this is small r, area is A, length is L and resistance is R. Now suppose I compress it. So if I compress it uniformly, it will become thicker. Okay, suppose they say radius has now increased. Now, suppose radius increases n times. Now be careful. If radius increases n times, area will increase n square times. Yes or no? If radius increases n times, area is pi r square formula. Right? So new area will be what? New area will be pi new radius. So new radius is n times. So n times r. Square is there, no? So you should not forget the square. So area will become n square pi r square, and pi r square is the original area. So please remember this fact, that if radius increases n times, area will increase n square times, which means length will decrease 1 by n square times. And you know, if length changes n times, resistance changes n square times. Here length changes this much times. So resistance will be 1 by n square times, which will be r by n power 4. So 4 will come if they give in terms of radius. Okay students, so try to revise this once. Okay. So basically the concept is, if length during stretching or compressing, if length changes by this factor, I should not say changes by actually, if it changes to this much, so this is something, let's say alpha, then your resistance will be alpha square L. Similarly, if length decreases 1 by alpha, then resistance will decrease 1 by alpha square times. Okay students, so try to remember this fact. Okay, let us see the next question now. Question number 24. It's an interesting question. Slightly different kind of question it is. The mean free path of electrons in a metal. What they are saying? Mean free path of electrons in a metal is 4 into 10 power minus 8 meter. The electric field which can give an average 2 eV energy. So energy given to the electron is 2 eV. Will be in the unit of volt per meter. How much? So how much electric field will be needed, they are asking, in order to give this much energy. Now try to understand first what is mean free path. So if you remember first few kinetic theory of gases, molecules used to move and collide with each other. Remember or not? And the average distance between two consecutive collision was called mean free path. Here also same thing. When electron is moving, it collides with the ions. Remember, right? So therefore, the distance between two consecutive collision. So one collision here, one collision here, let's say. So this distance, average distance is called mean free path. Let me write this distance as d. So let me write this distance as d. Usually we write lambda, but we can write it as d also. Okay. Now, listen carefully. This electric field will accelerate the electron during this interval I have told you in the theory classes. During this interval, the electric field will accelerate. Okay, the electron. Accelerate matlab what? Its velocity will increase, speed will increase. So kinetic energy will increase. So the kinetic energy given by electric field is 2 eV. Now, whatever energy is given, that I can write work done. The work done by the electric field, that itself is the energy which is given, right? And work done, how I can write? Force into distance. Force, how I can write? Q into E. So E will be what? 2 EV divided by Q into D. Now, this EV is not, this EV is only unit. I hope you know that. So 1 electron volt is unit of energy. So if you convert in SI unit, how much it is? 1.6 into 10 power minus 19 joules. So 2 EV will be 2 into 1.6 into 10 power minus 19 joules. And what is charge of electron? This is electron. No, electron is moving. So charge of electron in magnitude is 1.6 into 10 power minus 19 coulomb. And this D is this distance, which is given. Average distance is 4 into 10 power minus 8. So this 1.6 will cancel. 2 by 4 will be 0. How much? 1 by 2. So 0.5 into 10 to the power minus 19 minus 10 also cancel. So plus 8. So 5 into 10 to the power 7 unit will be, either you can say volt per meter or you can say Newton per coulomb. So please understand, this EV is unit of energy. Okay, energy, no, 2 EV. So you have to convert this into joules because we want the answer in SI unit, volt per meter. So which option is this? 5 into 10 power 7, option D. Option D. Now let us do 25. Now 25 and 26 is based on the formula of coefficient, temperature coefficient of resistance, that R2 minus R1 formula which I gave. But there is a small issue now. Okay, so concentrate properly. In NCERT, when we solve the numerical, we use this formula, R2 minus R1 equals to alpha R1 T2 minus T1. Now this is assuming that alpha is constant throughout the range of temperature. But students, usually that is not the case. That is why if you do more research on this concept, you will come to know that when we write this formula, we are writing it for a certain range of temperature. And the initial resistance should be always measured at some reference temperature. Some reference temperature. Okay, so that you will know that alpha is constant in that range around this reference temperature. Okay, so this R1 is taken as the initial resistance at some reference temperature T1. However, the reference temperature is not taken arbitrarily as 100 degrees Celsius or 200 degrees Celsius like that. So reference temperature is taken as 0 degrees Celsius. Okay. So now, if you take that into consideration, your formula will slightly change now when you want to connect resistance between two temperatures, different temperatures. Okay, so let us look carefully. So let us say R naught is resistance at 0 degree Celsius, which is your what temperature I have taken? Reference temperature. Then at any other temperature, let us say resistance is R at T degree Celsius. Then the formula connecting these two is R minus R naught equals to alpha R naught T minus reference temperature 0. So this will be R equals to R naught, you take that side, R naught plus alpha R naught T. So what will be R equals to? R naught common 1 plus alpha T. Okay, so this is the resistance at temperature T with respect to the reference with respect to resistance at what temperature? Reference temperature, which is taken as 0 degree Celsius. So this is the formula we should use provided your R naught is at reference temperature. So now, keeping this formula in your mind, if I ask what will be resistance at temperature T1, so let us say R1 is resistance at T1 degree Celsius and R2 is resistance at T2 degree Celsius. So if I say like this, then how this formula will be for these two resistance? R1 will be R naught 1 plus alpha T1, right? This same formula for writing for R1 at different temperature. And R2 will be what? R naught 1 plus alpha T2. So if you divide these two, what will you get? R naught will cancel, so you will get R1 by R2 equals to 1 by alpha T1 by 1 plus alpha T2. So this is the formula, please, you have to use for entrance purpose. In NCERT, they have not taken care of this. That is why they are directly using R2 minus R1 equals to alpha R1 into T2 minus T1. So this is the formula you should use to connect resistance between two different temperatures. So please memorize the formula. I have explained how it comes. So now let us see question number 25, or is it 26? Question number 25, yeah. So listen carefully what the question says. If the resistance of a conductor is 5 ohm, so resistance is 5 ohm at 50 degrees Celsius, and it is 7 ohm at 100 degrees Celsius. They are asking you to calculate temperature coefficient of resistance. So students, this is R1 at temperature T1, R2 at temperature T2. Use this formula, then only you will get the more correct answer. So if I use this formula, what will I get? R1 is 5, R2 is 7, right? This will be 1 plus alpha T1. T1 is 50 degree, 1 plus alpha T2 is 100 degree. So then you can simplify easily, right? If you cross multiply, this will be 7 plus 350 alpha, right? 750s are 350, and here 5 ones are 5, 500 alpha. Then bring this 5 this side, 2 will be equal to, this will go this side, 150 alpha. So alpha will be 2 divided by 150. So 1 by 75. So in what units, in what way they have given the answer? Okay, they want in terms of decimal number. So let us write this as 2 by 150 only. So 2 by 15, if you calculate 2 by 15, what will you get? 0.0, right? 15 ones are 15 and 5 carry 0.0, 15 threes are 3 fives are 15, 45. So you will get 0.13, 2 by 15 divided by 10. So 0.013 per degree Celsius. Why per degree Celsius? Because this is resistance, ohm will cancel, right? So this is no unit. So this also should have no unit. This is no unit. So this should have no unit. This is degree Celsius. So this should be per degree Celsius. So what is the answer? 0.013. 0.01, option A. Okay, so please keep this formula in your mind while doing problems in entrance exam. Okay, this is question number 25. Now let us see question number 26. This is also based on same concept. So in 26 they are saying the resistance of a wire is 5 ohm at 50 degrees Celsius. So 5 ohm at 50 degrees Celsius, and it is 6 ohm at 100 degrees Celsius. They want resistance at 0 degrees Celsius. They want resistance at 0 degrees Celsius. So what we should first do is first find alpha. So same procedure like we did, first find alpha. So 5 by 6, right, R1 by R2, 5 by 6 will be 1 plus alpha 50 by 1 plus alpha 100. Cross multiply, 5 plus 500 alpha will be 6 plus 6 300 alpha. Right, take this 5 that side, 300 this side, so 200 alpha will be 1. So alpha will be 1 by 200. Okay, basically we have just repeated the same kind of question. Now they want resistance at 0 degrees Celsius. Now R1 or R2, your wish. You can write R1 as what in the beginning I told, R naught 1 plus alpha T1. Remember, right? And what is R naught? Resistance at 0 degrees Celsius. So R naught will be R1 divided by 1 plus alpha T1. You can take R2 also, your wish. So what is R1 in the question? R1 is the first resistance 5 divided by 1 plus alpha is 1 by 200 into T1. T1 is 50. So 0, 0 cancels. So R naught will be 5 divided by 1 plus 1 by 5 divided by 20 will be 1 by 4. So if you take LCM here, this will be 4. 4 will go up. 20 divided by how much? 5. So 5 4s are 20. So answer will be 4 ohms. So answer will be option D, 4 ohms. Okay. Let us see question number 27 now. So 27 is based on now drift velocity. So please remember to use this formula. Okay, don't use the one that we have done in board syllabus. The reason why that one I did that way is because in order to match with NCERT answer, we have to use that formula only. So let us now see question number 27. A potential difference capital V is applied across a conductor of length L. Let's draw a picture, right? It's always nice to draw pictures. So there is a conductor and they have applied a potential difference V. If the length of the conductor is stretched, this conductor's length is stretched, keeping voltage constant, they are saying voltage is constant. The drift velocity of electron becomes how much? So by how many times drift velocity increases to, they are asking. So right now the length is L. Now if you stretch it to what length? Double length or what length? If the length is tripled, so length is now tripled. If the length is tripled, if you remember, area will become 1/3, right? Because of the volume should be constant during stretching. But they are keeping the battery same. Battery is same. Will the current be same? No, students, because by stretching resistance will change. Voltage is same, na? But resistance has changed, so current will change. So if I ask what is the current here, or let us directly write formula for drift velocity, which we know is current equals to NA VDE. But in these two problem, current is not same. So let us write current in terms of voltage. Voltage divided by resistance. Now, if this resistance is R, this resistance will be how much I have told you. Length increases 3 times. So resistance will become 3 square R, which is 9R. Okay, if you don't believe, use the formula rho L by A. Here you use rho L by A. Here you use rho L is 3L. A is A by 3. You will get 9R. Okay. So the resistance of this is 9 times this. So voltage is common. So if I now rearrange, what will be drift velocity? V divided by R N A E. Okay students, so now you can see voltage is same, charge of electron is same, number density is same because number density depends on material. So you can see drift velocity is inversely proportional to resistance and area. So I can write this as ratio. I can write V1 by V2. I can write R2 by R1 into A2 by A1 because it is inversely na. So V1 by V2 will be R2 by R1, A2 by A1. Now what is the initial resistance? Initial resistance I have assumed R. Final resistance is 9R. Initial area if I say is A. Final area is what? A by 3. A by 3. So A cancel, RR cancel, so it will be 3. So V2 will be cross multiply 1/3 of V1. So final velocity, final drift velocity. Final drift velocity is 1/3 of initial drift velocity. Check once. So it will be 1/3, 1/3, not triple, 1/3. So final velocity here will be 1/3. Another way to do is, instead of doing so many things, look here. R I can write rho L by A also. Yes or no? A will be cancelled. So now you can see resistivity is also same. So now you can see once A is cancelled, drift velocity is what? Inversely proportional to length. Length has increased 3 times. So drift velocity will decrease 3 times. So drift velocity will be 1/3 of initial drift velocity. So that way I think it will be easier to do than this one. Okay. So whichever way, just keep applying your basic concepts, and your proportionality concept should be very strong. Then you can do such problems very easily. Okay, let us see the next question now. Question number 28. Two manganese wires whose lengths are in the ratio 1:2. So length ratio is 1:2, and whose resistances are in the ratio 1:2, are connected in series with a battery. The ratio of drift velocity. Now, similar problem, current is NAVDE. Now, since it is in series, you know current will be same. So, no need to write current as voltage by R. See, always you have to try to find which quantities are same in the problem. In the previous question, voltage was same. So, I wrote the formula in terms of voltage. Remember, na? Here, current is same. So I am no need to write voltage because current is same. So when you take ratio, current will cancel. So drift velocity will be current divided by NAE. So current is same. Number density will be same because both are manganese wire. So ratio of drift velocity, it is inversely proportional to area. So it will be A2 by A1. Ulta. But they have not given area. They have given you this. So now you know R1 by R2. You can write rho L by A into, here this resistance you can write rho L by A. So A will go up. Resistivity is same because both are manganese wire. Now what is the ratio of resistance? 1 by 2. L1 by L2 is also 1 by 2. No, L1 by L2 is also 1 by 2. R1 by R2 is also 1 by 2. So 1 by 2, this L1 by L2 is 1 by 2. So from here this will cancel. So A2 will be A1. So if A2 and A1 are equal, this will come 1. That means drift velocity will remain same. Drift velocity will remain same. So 1:1, option C. Let us see question number 29 now. So this time there was no need to write in terms of voltage, but area ratio they did not give. Resistance ratio they gave. So we have used formula for resistance to find ratio of area. Let us see question number 29. You are given, listen carefully this question, very interesting. You are given several identical resistances, each of value R equals to 10 ohm. So you have many resistors like this. Many resistors. Several means what? Many are there. Each has value 10 ohm. Now they are saying each capable of carrying a maximum current of 1 ampere. So the maximum current here is 1 ampere. Each one of them. So each one of them can carry maximum 1 ampere. Maximum, okay? Matlab, if it is more than this, maybe the wire will melt. It will become fuse. So now they are asking, it is required to make a suitable combination of these resistances of 5 ohm, which can carry a current of 4 ampere. So how many number of resistances of this type will be required? So they want to combine these resistors so that you get a total resistance of 5 ohm and it should be able to carry 4 ampere current. Now you cannot put all of them in one line, because if you put all of them in one line and if you put 4 ampere, then this all of them will burn. All of them will burn out. So they can carry maximum how much? 1 ampere. They can carry maximum only 1 ampere. So it is very clear, you should put like this 4 of them in parallel, like this. In parallel you have to keep, so that since this can carry maximum 1, this combination can carry maximum 4 ampere. So 1 ampere will divide here equally. So if this branch, this branch, this branch, this branch, if these branches have same resistance, current will divide equally. So each one will get 1 ampere. So this way, this combination will be able to take 4 ampere current. Now we have to find how many resistors here we have used. So let us say here we have used n resistors. N resistors, n resistors, n resistors, n resistors. They must be equal so that this 4 ampere will divide equally. Now how to find this n? Listen carefully. This resistance is R, this is also R, and how many times I am writing? N times, because I am assuming in this line there are n resistors. So total resistance of this much, total resistance of this will be how much? NR. Similarly, total of this will be how much? NR, like that. Right? So the total combination, since this NR, this NR, this NR, this NR are in parallel, total resistance will be how much? NR by 4. You understood this concept or not? This resistance is NR, this is NR, this is NR, this is NR. They are in what combination? Parallel. So in parallel, how do we write? 1 by resistance total in parallel is 1 by NR plus 1 by NR plus 1 by NR plus 1 by NR. So 4 times, right? Because 4 branches are there. Why 4 branches? Because 4 ampere we have to divide equally. So that, because we know each one of them can carry only 1 ampere. And this one are in series, so current here will be same only. So this will become 1 by RT will become 4 by NR. So what will be RT? Take ulta, NR by 4. So now they told what is the total resistance they want. They want the total resistance to be 5 ohm. So this should be 5 ohm. And each R, each resistance R has how much value? 10 by 4. Cross multiply, you will get 2. That means here we should put 2 resistors. So the total number of resistors required will be how much? How many branches are there? 4 branches. 4 into, and each branch should have how many resistance I found? 2 resistors. 2 resistors. So total how much I need? 8 resistors. Right? It is like saying 4 benches are there and 2 boys are sitting. So how many number of boys will be there? Number of benches into number of boys in one bench. Let's see the next question now. Question number 30. 30 we have done exactly in the class itself. So please do it yourself. Question number 31, students, we will not be doing right now. For 31, we need to know something called how to find equivalent resistance using axis of symmetry. So later we will do. Very interesting problem. 32, let us do now. 32, let us do. So the total resistance of two resistances when connected in series is 9 ohm, and when connected in parallel the total resistance is 2 ohm. What is the value of each resistance? Simple. So in series, what is the total resistance? R1 plus R2. This is in series, na? And what is the value they have given? 9 ohm. So in series, we have to add the resistance. And when they are in parallel, the total resistance is 2 ohm. So in parallel, how do we write the formula for total resistance in parallel? For two resistors, how do we write? For two resistors, R1, R2 by R1 plus R2. And this is given 2 ohm. So these two we have to simplify. So what we can do, R1 plus R2 is 9, so substitute here. So R1, R2 divided by R1 plus R2 is 9. That will be equal to 2. So R1, R2 will be 18. Okay, so now instead of solving, let us just check the options. So the options should be such that R1 and R2 should be such that when you multiply, you should get 18. When you add, you should get 9. So 7 and 2, not correct, because 7 and 2 when you multiply, you will not get 18. 6 and 3 are correct. 6 and 3, if you add, you will get 9. If you multiply, you will get 18. So option B. 30 again we have to use axis of symmetry. So we will not do now. 34 also we have to use axis of symmetry. 35 we can do. So whichever we are not able to do right now, later once I discuss in the regular class, online class, I will explain. So let us now do question number 35. The total current supplied by the battery they are asking. The diagram is very interesting. So there is a circle like this. Here they put a battery, 6 volt. This is the center somewhere here. Here 2 ohm is coming. 2 ohm. Here 1.5 ohm. Here 6 ohm. And here there is 3 ohm. So we want current here. Current coming from the battery. Supplied by the battery. So what you should do, you should try to simplify the circuit. So now look carefully. These two you look carefully. These two. If you look carefully, these two you can see here. This terminal and this terminal are joined directly. And this terminal and this terminal are also joined directly, no? Because it is nothing is there, no resistance is there. So these two are in parallel. These two are in parallel combination. Parallel combination means what I told. If you have two resistors like this, these two should be joined directly, these two should be joined directly. Directly matlab only wire should be there. Nothing should be there in the middle. So you can see between these two there is a wire, and here also there is just a wire. No resistors are there in the middle. So those two are in parallel. So what will be the total resistance? 6 into 2, 6 plus 2, 12 by 8. So 4 2s are 4 3s are 1.5 ohm. So you can replace these two by 1.5 ohm in between these two terminals. So let us redraw the diagram now. So battery is still there, right? Battery we have not done anything, no? And this 1.5 is still there. And this can be replaced by one single resistance. These two. How much? 1.5. Okay, and this 3 is also there. Right? Like this. Now you look carefully. These two are in what combination? This is 1.5. So these two are in now series combination. Series combination. So total will be how much? 1.5 plus 1.5. That will be 3 ohm. So you can replace these two by 3 ohm. So again you draw one more simplified diagram. Here battery, here 3 ohm, and this 3 ohm is also there, and this battery was 6 volt. Now you can see these two are, see, these two are joined directly here, these two are joined directly here. So these two are in what combination? Parallel combination. So total will be how much? R total. 3 into 3, 3 plus 3. Correct, no? So it will be 9 divided by 6. 3 by 2, which will be 1.5 ohm. Right? So once we know the total resistance seen by the battery, so then finally, if I redraw the circuit, this will be 6 volt battery, and combination of these two will give you 1.5. So now you can see the current coming from here can be easily found from Ohm's law. So current coming will be potential difference divided by resistance. So 60 by 15. So it will be 5 3s are 5 1s are 5 2s are 3 4s are. So answer is 4 amperes. Okay. Very interesting question, na? So 4 amperes means option C. 36 also, students, we have to use symmetry, axis of symmetry. So what is the meaning of axis of symmetry? Later I will explain, but right now let me tell you just something. See, every time, no, you will not be able to decide whether two resistors are in series or parallel. So for example, right now I know these two are in parallel, so I was able to simplify. Sometimes you will not be able to decide only. So that time, axis of symmetry will be very, very useful. So that's why those questions we will do later after I explain in the theory class. Now let us solve 37. Also we have to use axis of symmetry. 38 onwards it is something else. Batteries and all that, internal resistance and all we have to discuss later only. 39 I can teach now. So in 39 what they are saying, two metal wires of identical dimensions are connected in series. If sigma 1 and sigma 2 are conductivities, they are saying, then the effective conductivity means equivalent conductivity. So similar problem I did previously, but it was equivalent resistivity. Here equivalent conductivity. So this time they told dimensions are same. So two wires having same dimension are connected in series. So this has conductivity sigma 1, this has conductivity sigma 2. If you replace this by one wire between these two, then what will be the conductivity of this, they are asking. Effective conductivity. So simple again, this resistance is R1, let's say R2, this is R. In series, how will I write R? R1 plus R2. What will be R1 here? Rho L by A. Rho L by A. L is same. Length is same because this time they are identical dimension. And this will be what? Rho effective. L will be what? Length will be not L. Remember, this is L, this is L, this is L, this is L. So this will be 2L. Area will be same. If this is area A, this will be also area A. So it will be rho effective L plus L 2L divided by A. So A you can take common and cancel. So rho effective will be rho 1 plus rho 2 divided by 2. But you may think, but sir, they asked what? Conductivity. Now what is the relation? Conductivity is reciprocal of resistivity. Or you can say resistivity is reciprocal of conductivity. So bring these two back here. It will be easy. Keep these two here only. So how I can write rho effective? Rho effective I can write 1 by sigma effective. Because resistivity is reciprocal of conductivity. And this one I can write 1 by sigma 1 plus 1 by sigma 2. So 2 by sigma effective will be, LCM will be sigma 1, sigma 2, here sigma 2 plus sigma 1. Cross multiply. Equivalent conductivity of this material will be 2 into sigma 1, sigma 2 by sigma 1 plus sigma 2. Okay. So which is the right answer? Option A. 40 we have to do later, 41 later, 42 later. I think, yeah, these are the questions for NEET which we should do. Now we will do 46. These are questions which are based on power consumption. So in theory class, we have already discussed power consumption, right? So let us just quickly think. If there is a single resistor, power consumed, we write either I square R or we write V square by R. Okay, any two formula you can use, any one you can use. Now, when there is a circuit and they will ask total power consumed, then what you should do is you have to find the equivalent resistance. And if you know the voltage of the battery, use this formula. If you know the main current coming from the battery, then use this formula. Okay, so total power, if they ask, use total resistance. Total resistance. Okay, so see question number 46 also, students, we cannot do right now because the first circuit diagram we have to use symmetry of axis to find the equivalent resistance. So we will do later. 47 we will do now. So in question number 47, they are saying in the circuit power dissipation is 150 watt. In the circuit they told. That means that is the total power consumed by the circuit. So total power consumed is 150 watt. Then they are asking the value of R. So diagram is there is R here and here there is 2 ohm and voltage of the battery is given 50. Total power they have given. So it's very simple, right? So what is the formula for total power consumed? Either you can write main current square into resistance or voltage square by resistance. Here we know voltage. So I will write voltage square by total resistance. So what you have to do? Replace these two by one resistor. Then the power consumed by that single resistor will be the total power consumed, obviously. That is why we are calling it equivalent. So what is the total power consumed? 150. Voltage is 15, so 15 into 50 divided by RT. So total resistance will be 15 ones are, this 15 will cancel. So 15 by 10. So this is the total resistance. Now how I can write total resistance for these two? These two are in what combination? Parallel. So how I can write R into 2, R plus 2. Correct na? In parallel. And this I can write 5 3s are 5 2s are. So cross multiply. This is 2R, no? So if you cross multiply with 2, 4R will be equal to, here if you cross multiply, 3R plus 3 2s are 6. Bring this 3R this side. So R will be 6 ohm. Okay, simple question. R is 6 ohm. Option B. Question number 48 you see now. All these are very interesting questions based on power consumption. So if they give you more than one resistor and they ask total power, please calculate the equivalent resistance first. Now here, question number 48, you listen carefully. For the circuit shown, if heat produced in 5 ohm resistor, heat produced in 5 ohm resistor is 10 joules per second. That is actually power because they have given per second. Then heat produced in 4 ohm resistor they are asking. So diagram is given like this. Here 4 ohm, here 6 ohm, here 5 ohm, and current coming from here is not given. It is not given. Okay, but they have given here power consumed by 5 ohm alone only by this resistor. Okay, not total power they have not given. So power consumed by this one is given 10 watts. Joules per second means watts. Now what we can do, since I know the power consumed by this and I know resistance, this current coming here will divide. No, here will be I1, here will be I2. So this I2 we can find. So this power I can write I2 square into resistance. I2 square into resistance. Resistance of this is 5. So I2 will be 10 divided by 5 will be 2. So root 2 amperes. So current flowing here is root 2. Everybody understood, right? 10 by 5 will be 2. This is I2 square. Na? So current here I came to know. Now they want power consumed by only this. So I have to find this current. Now for that what I will do first. First let me, this 4 and this 6. I can consider this as 10 ohm in parallel. Sorry, in series. So this 4 and this 6 are in series. So total will be 10. And here 5. Correct na? Okay. Now here current going is I1, because in series you know same current will flow in series combination. And here current is I2. Now see here, we have done this kind of problem. These two are in parallel. So if it is in parallel, what will be same? Voltage will be same. So what is the voltage here? I1 into R. R is 10. What is the voltage here? I2 into R. What is R? 5. So from here I1 by I2. I1 by I2 will be 5 by 10, 1 by 2. But I2 I know. I2 is root 2. So I1 will be here, I2 is root 2 divided by 1 by 2. So cross multiply. I1 will be 1 by root 2 ampere. No, just cross multiply. Root 2 will go in the numerator. Root 2 divided by 2 will be 1 by root 2. So I found current here. Once I know current here, I also know that current will be here. So power consumed by this one they are asking. Not power consumed by 10 ohm. Power consumed by 4 ohm they are asking. Current will be same in 4 ohm and 10 ohm. Why? Because it is in series. So current flowing here will be I1. So power will be I1 square into this resistance, which is 4. So I1 is how much? 1 by root 2. Square will be what? 1 by 2. No, 1 by root 2 square is 1 by 2 into 4. So answer is 2 watt. Similarly, you can find now power consumed by this also. What will be power consumed by this? Power consumed by 6 ohm. Current will be I1 only. So I1 square into 6. I1 is 1 by root 2. So 1 by 2 into 6. That will be 3 ohm. So total power consumed by these two will be 2 watt plus 3 watt. 5 watt. 5 watt plus this is 10. 15 watt. So total power consumed also, if they ask, we can answer now. Here how much? 2 watt, here 3 watt, here 10 watt. So total will be 15 watt. But here the answer is this, because they only wanted power consumed by this resistance. So before finding I1, students, you have to consider these two as equivalent of these two here. Then you can easily find. Because once you put these two, if you replace these two by one resistance, then you can see these two are in parallel. So easily you can find the current. Okay. 49. Okay, let us do 49 now. Okay, let us solve question number 49 now. Listen to the question. Okay, so they have given you one circuit diagram, and these are three bulbs. Bulbs P, Q, and R are identical bulbs. So in the question, they should use the word identical bulbs. Otherwise, we won't be able to solve. So please mention their identical bulbs. Since they are identical bulbs, each one will have same resistance. But I will not write capital R because they are using capital R to denote this bulb. So I will write resistance as small r. So each has resistance small r. Now they are asking, when this switch is closed, how will the brightness of these two bulbs change? How will the brightness of these two bulbs change? So what we have to analyze? First we have to analyze when the key is open. Then we have to analyze what happens when the key is closed. So initially, this is the initial diagram. Whatever current is coming from the battery, same current will go here, and here the current will not go because this is open. Since it is open, no current will go that side. So all the current, same current will come here, and it will go like this. Okay, students? So the current flowing in this bulb or in this bulb will be how much? Voltage is V, total resistance of the circuit this will be useless because no current is going that side. So the total resistance as seen by the battery will be how much? R and R in series. Why series? Same current is flowing. So R and R in series will be 2R. So this is the situation right now. So what will be the power consumed by this? I square into resistance of this. And what is the power consumed by this? I square into resistance of this. So right now, these two bulbs will glow equally because they are consuming equal power. Why equal power? Resistance is same, identical bulbs. Current is also same because these two are right now in series. Now look carefully. When you will close the key, this circle I am putting just to remind you it is a bulb. Just to remind you it is a bulb, I am putting a circle. Now look here. Once you close the key, now this also will play some role. So now the current coming from here, let us call that current I dash. I dash. So current flowing here will be I dash. What will be I dash? Voltage is same only, but total resistance will be how much? Look carefully. This is small r, this is small r. They are in parallel. So parallel means what? 1 by r plus 1 by r, 2 by r, ulta, r by 2. So total of this is r by 2 plus this r in series. So that will be 3r by 2. All of you understood, right? How I got this total resistance? R and R in parallel will be R by 2. R by 2 in series with R will be R by 2 plus R. That will be 3R by 2, which will be 2V by 3R. So that much current will flow through this bulb, which is which bulb? P bulb. Now, how much current will go here? Since these two have same resistance, current will divide equally. So current here will be I dash divided by 2. I dash divided by 2. So let us calculate the current here. Current here, well, let us call this I double dash. That will be I dash divided by 2. So what will be current flowing here? This divided by 2 means V by 3R. Correct na? If you divide by 2, 2 will cancel. So now let us calculate, let us analyze the currents. What was the current here? I, which is V by 2R. What is the current here now? 2V by 3R. So 1 by 2 means 0.5 V by R. Here this will be 0.6 something, 0.67 V by R. So you can see I dash is greater than I. Since current here has increased compared to here, resistance is same, but current has increased. So power will also increase. So power consumed by P bulb will increase. So brightness will increase. Brightness will increase. For which bulb? P bulb. Now come to this. This is getting how much current? I, which is how much? 0.5 VR. And how much this is getting? 1 by 3. 1 by 3 will be how much? 0.3 V by R. 0.33. So now this current here is less than here, see, compared to before. So since I double dash is less than I, current flowing here now is less than before. That means power consumed by this bulb, which is R bulb, will decrease because resistance of this is R, resistance of this is R only, but current here has decreased. So if current decreases, I square R will also decrease. So power consumed by this bulb will decrease. So brightness of this bulb will decrease. So what is the right answer? Brightness of P increases, but that of R decreases. So option A. Please see this video once more so that you understand properly. This question you see once more. Okay, let us do question number 50 now. So in 50th question they are saying a coil connected to a supply V volt consumes power P. So there is a coil and every coil will have some resistance. When it is connected to V volt, it consumes power P. So since V volt is mentioned, what formula I will write? V square by R. Now, if the wire of the coil is cut into two equal parts, if you cut into two equal parts, what will happen? Length will become half. If length will become half, area will not change because we are cutting, we are not stretching. So if you cut, length will be half, area will remain same only. So resistance is proportional to length. So if length is half, resistance will be also half. And these halves are connected in parallel now. And same voltage is applied. What will be the power consumed by the combination? So you are cutting this into two parts. So each one will have what resistance? R by 2. Now you are connecting them in parallel combination. So after cutting these two, each one will be R by 2. Then they are connecting them in parallel combination. After cutting them, each one will have R by 2. Then they are putting in parallel. And they are giving the same voltage. Remember, same battery is connected. So what will be the power consumed by this combination? So now total power will be what? Voltage is same by total resistance. What is the total resistance of R by 2 and R by 2 in parallel? 1 by R by 2 plus 1 by R by 2. Yes or no? So it will be 1 by R total. Parallel, no? 1 by R by 2 plus 1 by R by 2. Simplify, you will get R total as R by 4. This 2 will go up, this 2 will go up. 2 by R plus 2 by R, 4 by R. Ulta will be R by 4. So now it will be V square by total resistance is R by 4, which will be 4 times V square by R. What is V square by R? The initial power. So it will become 4 times initial power. So whatever power this wire was consuming, now it will consume 4 times more power. Okay, so if you cut the wire into two equal parts, each will have half resistance. Then you are connecting them in parallel. Then the resistance will become R by 4. Total will be R by 4. Voltage is same, remember, in this problem. So please use the formula V square by R. So let us see now question number 51. Okay, direct question. It is based on power formula, current into voltage. So here they are saying in a large building, there are 15 bulbs of 40 watt and 5 bulbs of 100 watt, 5 fans of 80 watt and 1 heater of 1 kilowatt. The voltage of the electric mains matlab the main supply. So the main supply given to all this building, the whatever devices are there, the main supply is giving 220 volts. What is the minimum capacity of the main fuse of the building? So here options are given in amperes. So they want the current that should flow through the mains. So what we should do? Calculate the total power. So total power, if every device is glowing with this brightness or this watt, whatever power they have given, then total power will be how much? 15 bulbs of 40 watts. So this will consume how much watt? 15 into 40. So that will be 5 4 2600 watt. So these 15 bulbs together, all of them together, if they are glowing, it will consume 600 watt. This will be 500 watt. This will be 5 into 80, 400 watt, plus one heater which is 1 kilowatt. 1 kilowatt means 1000 watt. So this will be 2500 watt. So that is the total power consumed by the circuit. So I can now write total power consumed as current, the main current and the main voltage. Okay, so the main current flowing will be total power by total voltage. Total power is 2500. Main voltage is 220. So 0 can be cancelled. 11 2 ones are 2, 2 ones are 2, 2 ones are 2, 2 twos are 4, 2 fives are 10. 11 ones are 11, 1 carry, 11 ones are 11, 4 carry, 11 threes are. So it will be approximately 11.3 ampere. Now options are given what? 8, 10, 12, 14. So closest answer is 12. Okay. Let's see the next question now. Question number 52. This question we have done in class only, but let us revise it. An electric bulb A rated 220 volt and 60 watt. Rated they are saying. So rating of the first bulb A is 220 volt 60 watt. That does not mean it is consuming 60 watt. What it means, if you apply 220 volt voltage to the bulb, then it will consume 60 watt power. Similarly, rating of the second bulb is 220 volt. As I told you in the class also, the rated voltage will be always assumed constant, 220 volt. And what is the power? 40 watt. Now the combination is connected across a source of EMF 220 volt. In what combination they did not say actually. So they should have mentioned series combination. So that they should mention, okay, series combination. Which bulb will glow more they are asking. So in series. So in series we know current will be same. So in series, since current will be same, I will use this formula to determine the resistance between power consumed, not rated power. So power consumed will be more for bigger resistance in series. So whichever has more resistance will consume more power, therefore it will glow more. Now how to find which one has more resistance? See, since here rated voltage will always be taken common only. So for rated voltage, what formula we can use? Rated voltage, rated power will be rated voltage square by resistance. Remember, resistance will be same no matter what voltage we apply. So you can see rated voltage is same. That will be assumed same only. Even if they don't tell, it has to be assumed same. So whichever will have less rated power or more rated power will have less resistance. Understood? So here which has more rated power? This has more rated power. So this will have less resistance. So resistance of A will be less than resistance of B. That we have to decide from the rated power and the rated voltage. Rated voltage will be taken common only. So when manufacturer will make bulbs, he will always assume voltage is same, and then he will design different resistance depending on the power requirement. So this has more power, so he will make this one having less resistance. Now if you connect them in series, then in series we know the one with more resistance will always consume more power. So which one has more resistance? B. So power consumed by B will be more than power consumed by A. So bulb B will glow more. Whichever has more power consumed, obviously it will glow more. So option B. Let us see question number 53 now. Three identical resistors are connected in series. When a certain potential difference is applied across the combination, the total power dissipated is 27 watt. How many times the power would be dissipated if the three resistors were connected in parallel across the, see, listen carefully, across the same potential difference, so same voltage. So first time what they have done, they have put three identical resistors in series and given some voltage. Let's say R, identical na, so R. That time the total power consumed is given 27 watt. Now they are connecting the same resistors in parallel, and they are giving the same potential difference. So what will be now power consumed, they are asking total power. So let us discuss quickly. So since many resistors are there, single resistor is not there, what we have to do, convert this into single resistor. So what will be total resistance of this? Total resistance of this will be 3R. Why? Because it is in series. So total power will be V square by R. And what is total resistance? 3R. Correct na? Okay. Now here, what will be the total resistance? Since it is in parallel, total resistance here will be R by 3. 1 by R plus 1 by R plus 1 by R, then ulta you do. R by 3. So total power will be, voltage is same. So V square by total resistance, R by 3. So 3 V square by R. So now the total power will be 3 times V square by R. What is V square by R from here? 3 times initial power. So the answer will be 9 times initial power. And what was the initial total power? 27. So 9 into 27. 9 7s are 63. 3 6 carry. 9 2s are 18. 18 plus 6 24. So 243 watt. So now the power consumed will be, oh sir, they are only asking how many times the power will increase, not the total power. So how many times the power increase? 9 times. So answer is 9 times. This is the answer. Total power also we can calculate, but here they only asked how many times the power increases to. Okay, let us see 54 now. 54 is simple but slightly unique, different problem. So in question number 54 they are saying, if 400 ohm resistor is made by adding 400 ohm resistances, 400 ohm resistor is made by adding 400 ohm resistor, matlab in series, of tolerance 5%. Tolerance means what I told yesterday also when I was discussing the third day of our video class. I told it is the percentage error. So tolerance is 5% for each resistor. What will be the tolerance of the combination? Since it is in series, total resistance will be, how many resistors are they are using? 4 resistors. So total resistance will be 4R. Now this is a constant, so you know from your concept of error analysis in first PU. Since this is constant, relative error will be, power here is 1, no? It will be delta R by R only. Power is 1. So if you multiply by 100, this will become percentage error. So percentage error in each resistance is given 5%. So percentage error in combination also will be 5%. So percentage error will be same for both of them, whether it is individual resistance or total combined resistance. Percentage error will be same, because this 4 is just a constant that will not come when you write the formula for relative error. Only this power comes. Okay, let us 55 we have to do later only. 56 let us see now. Okay, 56 also we have to do later. So 56 and 57 are actually based on something called potentiometer, which we have not discussed till now. So we will do it later. So JE NEET problems are done. Let us start JE problems now. So JE problems, these are all capacitor problems which we have already covered. Question number 21 you see. So now we are going to discuss JE problems starting with question number 21. Before I discuss this question, if you remember the formula for current density, current per unit area. But I told you this is only true when current density is constant. Then we can write current by area. So to find the current, what I can do, just cross multiply. But then I told if current density changes from point to point on the area, what is this area? See, some area A, no? And this I is the current flowing perpendicularly. Then we define current density, current per unit area. Okay? But if your J is a function of distance here, so from point to point on this area, if the J is changing, then how to find current? You have to integrate JDA. Okay, so if you remember the theory class, that time also I have told you that if J is not constant, then first you have to find small current through a small area, then you have to integrate to find the total current. So remember this concept. So now listen carefully to this question. A cylindrical conductor carries a current such that the current density varies with radial distance r. So there is a cylindrical conductor, let us say like this. This is the axis, and this small r represents the radial distance. Okay, so this small r represents the distance from the axis of the wire. So the current density is function of this r they are saying. Current density is not a constant now. Current density is given some constant A into r square. That means when r is small, current density is small. So as you go away from this axis, radially like this, radially. Okay, radially as you go, your current density is increasing because it is proportional to r square. So they want current through the outer portion of the wire between the radial distance r by 2 and r is proportional to r power k, where r is the radius of the wire. So r is the radius of the wire, and they want current through the outer portion of the wire between radial distance r by 2. So this will be your r by 2. So between this and this, what is the current? This much part they want. And they are saying that current is proportional to r power k. That k we have to find. Okay. So the best way to do this problem is to see from this side. See from this side. Okay, current will be flowing like this. So if you see from this side, imagine this is what you see. So from this is the radial distance r. So what you do is first you take a small ring here. Small ring. Okay. Whose thickness is dr. If this is the radius of the ring, then thickness will be dr only. So this area will be how much? dA. So this area will be 2 pi r into dr. Already we have discussed before also. So this length is 2 pi r circumference into thickness. If you cut this and open, it will be a rectangle. Already I have explained to you, right? So this length is 2 pi r, thickness is dr. So this is the area of this thin section of this disc. From here, if you see, this will look like a disc, no? So this is a small ring, a small part of the disc. Now, current coming from that disc will be di, small current. Not disc, sorry. Current coming from that small ring will be di. That will be whatever is the current density here into area of this. Right? I told you this formula. When J is not constant, this is how you have to write current. Directly don't write current equal to J into A, because J is changing from place to place. So as you go radially outwards, your J is changing. It is a function of this radial distance they told. Of course, everywhere here J will be same because I am at same radial distance. Right? Okay. So di will be J into dA. So di will be J at this location. What will be J? They have given A into r square. And what is the area of this ring? pi, sorry, 2 pi r dr. Correct na? Okay. So this is the current through this ring. Now they want current between capital R by 2 and R by 2. In this much part only they want. So what we have to do, you have to integrate this from R by 2 to R. If they want total current, then what will you do? You have to integrate from 0 to R. If you want total current, then what will you do? First find current through this ring, then through this ring, then through this ring, then through this ring, right? You cover the whole disk starting from this ring till you reach this ring. So if they want total current coming through the disk, through the cylinder, then you have to write from integration from 0 to R. But here they only want between R by 2 to R. Matlab in this much portion only they want. So you have to integrate from R by 2 to R. So you have to integrate the small current. This is the small current. So you have to integrate to find the total current. So A into R square 2 pi R dr. Now constants you take outside. So if you take the constants outside, what will you get total current? 2 pi A is constant, integration of R power 3 dr, R by 2 to R. So integration of x dx is x square by 2. Integration of R power 3 will be what? R power 4 by 4. So 2 pi A R power 4 by 4. Upper limit is R, lower limit is R by 2. Substitute. So if you put upper limit R power 4 by 4 minus R by 2 power 4 by 4, 1 by 4. Right? So if you take R power 4 common, it is very clear that the current between R by 2 and R is proportional to R power 4. Right? If you take R power 4 common, then it is proportional to R power 4. In the question they told it is proportional to R power k. So what will be this k equal to? We have found it is proportional to R power 4, na? So k should be 4. So that will be your answer. So again try to understand. If this is the cylinder, if this is your cylinder, okay, through different rings, if you divide this from, see, though it is a cylinder, from here if you see it will look like a disc. Now you can imagine this disc is made up of small rings like this. Now if J was constant, then it doesn't matter. Then to find the total current, what will you do? Just multiply J with area, total area. But if J is not constant, then you have to divide this into small rings. First find current through one ring, then you integrate to find the total current between some limit to some limit. Now if they want total current through the whole cylinder, the current coming out through the whole area, then you integrate from 0 till you reach capital R. But if they want only in this portion, then you integrate from here till here. Okay, in the question it was from R by 2 to R. Okay, so here the answer is option D. Option D. Now see the next question. So in the next question what will happen is there will be two different materials connected in series. So look carefully. Question number 22. Figure below shows two rods having same cross-sectional area with conductivities sigma 1 and sigma 2 in series. So there are two material like this in series. Okay, with conductivities here sigma 1, here sigma 2. So materials are not same. A current I flows through the combination. In series current will be same. Now they want you to calculate the total amount of charge at the junction of the two materials. So they want the total amount of charge at the junction. So at this junction there will be some accumulation of charge. So that charge they want. Now how to understand why there is charge accumulated? Very simple, look here. Since materials are different, electric field here and electric field here cannot be same. It has to be different. Now, what is the reason? You know that current will be same, area is same. So current density will be same here and here. Because current is same, area is same. And current density is what? Current per unit area. So current density here and here are same. Now what is the formula for current density? Sigma into E. Right? If conductivity was same, then electric field will be same. But conductivities are different. So sigma 1 E1 equal to sigma 2 E2. So it is very clear electric field here and here are not same. If electric field here and here are not same, then there must be some charge accumulated here. To understand this, what you do? Draw a Gaussian surface here. Draw a Gaussian surface like this. This is your Gaussian surface. Okay. Now what will be the total electric flux? If I call this area A, okay, or better to consider this as your Gaussian surface because I want the total charge. So let me consider this as my Gaussian surface. So if that is my Gaussian surface, if this cylinder is my Gaussian surface, then what will be the total electric flux? Through this area, electric field is here. Area vector will be always outward from this volume, outward. So electric flux here will be E2 into A. Right? Electric field is here. Area vector also is here. So electric flux is electric field into area into cos theta. Cos theta here will be 1. Similarly, what is electric flux through this area? Area vector will be here, remember. For this area vector will be here. Area vector for a closed surface is always drawn perpendicular to the surface and outward from the enclosed volume. So this is the enclosed volume. So area vector is always drawn outward. So what will be the electric flux through this surface? Electric field is here because current is flowing this way now. So electric field will be here only. But area vector is here. So what will be the electric flux through this? E1 into A. And cos 180 will be there because directions are opposite. So minus. So this is the net electric flux. Net electric flux through the closed surface. According to Gauss law, this should be equal to charge inside, which they are asking you. Charge inside this is this charge, no? So charge inside divided by epsilon naught. Okay. So charge inside will be what? Epsilon naught into E2 minus E1 times A. Okay. Now, so if you see the options, there is no E2, E1. It is in terms of conductivity. So what I can do now is from here I can write either E2 or E1. Let us decide. So E1 I can write sigma 2 E2 by sigma 1. Correct now? So let us substitute this E1 here. Then what will be the charge inside this Gaussian surface? Which means charge on the junction. So that will be equals to epsilon naught E2 minus E1 I can write sigma 2 by sigma 1 into E2 times A. Correct na? Okay. So then if I take E2 common and then take it outside, I will get Q equal to epsilon naught 1 minus sigma 2 by sigma 1 E2 into A. Now how can I write E2 into A in terms of current? Because the option has in terms of current. Now what is current equals to? J into A. J is same everywhere. So I can write J as sigma 1 into E1, or I can also write sigma 2 into E2 into A. So since I wrote here, since I have E2 into A, I can write this E2 into A as I divided by sigma 2. E2 into A, I can write I divided by sigma 2. This I am doing so that I can write the answer in terms of current. So it will be epsilon naught 1 minus sigma 2 by sigma 1. E2 into A, I can write I by sigma 2. Okay, then let us see the option now. Okay, still it is not matching with the option. So let me take sigma 2 inside now. So if I put sigma 2 inside, it will be 1 by sigma 2 minus 1 by sigma 1 times current. So this should be the answer. So option B. So please try to realize this question. Very interesting question again. If the materials are different, then electric field here and here has to be different. If electric field is different, there must be some charge on the junction. Without that, how can electric field be different? See this formula. Okay, so if electric field is different, if I draw a Gaussian surface, there will be some net electric flux, which means there must be some charge inside or at the junction. And that junction is, and that how much charge will be there? This much. What if the material was same? Suppose it was one copper wire, just one copper wire. Then these two conductivity will be same only. Then it will be 1 minus 1, that will be 0. Then there will be no charge on the junction. If it is just one copper wire, if it is just one copper wire, then we don't speak about junction also, right? But if different materials are there, then there will be some charge on the junction which is responsible for changing the electric field from E1 to E2. Please remember that. So please try to understand this carefully. Now one question while doing the entrance corner in the EPL, the first question, if you remember, I skipped it. I told this is little complicated right now. Now I can explain that question to you. So in that question, very good question in NCERT. Okay. So if you have understood this, then try to see the entrance corner first question, which I skipped. So now we will be able to understand. So what they are saying is, in the question they told there is a circular wire and current is I. Current is I. Area of cross section, this area. If this is the wire, then this area is constant, uniform wire. So J is constant in magnitude, but J is a vector, remember. So J is changing from here to here, from here to here, J vector will change. So from here to, as you go from point to point on the wire, J vector will change. So they are asking you what is causing this change. They are asking what causes the change. So if you analyze this question now, you can think, since J vector is changing, it means E vector will also change. So if E vector is changing, like in this problem, E1 here and E2 here are not same. Understood or not? Since the vector, if the electric field is changing, then there must be reason due to some charge accumulated on the surface. So charge accumulated on the surface. So you can easily find this option in one of the four options of that question. So wherever they write charge accumulated on the surface is responsible for changing the electric field vector, that you can take. Now you have understood. But that time if I explain, no, you will not understand. Okay, students? See question number 23. So they have given VI graph for a conductor at temperature T1 and T2 are given. So here they have plotted voltage, here they are plotting current, and for two different temperatures. This is for T1, this is for T2. You know that when you change temperature, resistance will change. If resistance will change, slope of the graph will also change, right? So you know that V equals to IR. Here V is along y-axis, current is along x-axis, right? So this resistance must be your slope, y equal to mx. So this graph has more resistance, so this graph has more slope. So more slope means more resistance, therefore more temperature. So question is, they are saying this angle is theta and this angle is also theta. So they are asking T2 minus T1 is proportional to cos 2 theta, sin theta, cot 2 theta, tan theta. So in terms of theta, they want this difference of temperature. So how to do it? See, you know R is the slope. So for this, if I write resistance as R1 at this temperature, if I write resistance R1, then that will be slope of the graph. Slope is tan of angle made by the line with x-axis. So that angle is theta, right? For second temperature, if I write resistance R2, what will be slope? Tan of this angle. Remember, whenever you measure slope, you have to measure the angle with x-axis, not this angle. So here this line makes theta angle. So this angle will be what? 90 minus theta. So slope will be 90 minus theta. That will be cot theta. Okay. Now how to bring difference in temperature? Just in the previous section I told you, R1 I can write R naught 1 plus alpha T1, temperature T1. R2 R naught 1 plus alpha T2. So if you subtract R2 minus R1, R0 into 1, R0 into 1 will cancel. Then R0 alpha common, T2 minus T1. This is what will you get. So R2 minus R1 will be R0 alpha T2 minus T1. But what is R2? Tan theta. And what is R1? Cot theta. So it is very clear that this difference in temperature is proportional to this. Okay, so we have to simplify this. So now if you know trigonometry, this will be very easy. So let us check. Difference in temperature T2 minus T1 is proportional to this angle. I mean this expression, tan theta minus cot theta. So we have to simplify this. So what will be this? Sin theta by cos theta minus cos theta by sin theta. Then if I take LCM, it will be sin theta cos theta. Here cos cancel, sin square theta minus cos square theta. Okay, now you must be knowing sin square theta minus cos square theta. Sin square theta minus cos square theta is cos 2 theta. And sin theta cos theta I can write. Let me multiply by 2 and divide by 2. Then I can write 1 by 2 sin 2 theta. 1 by 2 is constant only. So from here you can see T2 minus T1 is proportional to cos 2 theta divided by sin 2 theta, which is cot 2 theta. Okay, so quite a simple question, but you need to know a little bit of trigonometry. Let us see question number 24. So in 24 they are saying a 1 microfarad capacitor is connected in the circuit shown below. The EMF of the cell is 3 volt and the internal resistance is 0.5 ohm. The resistors R1 and R2 have values 4 ohm and 1 ohm respectively. The charge on the capacitor they are asking in steady state. In steady state. So here there is a battery. Here there is a resistance 0.5 ohm. Voltage of the battery is 3 volt. Here there is a capacitor. Here there is R1 which is 4 ohm. And here 1 ohm R2. Now in steady state they are asking. In steady state, what will happen? In steady state, the capacitor will be fully charged. And once the capacitor is fully charged, please remember this. Let me write it in a sentence. In steady state, no current flows in the branch containing the capacitor. So in that branch where there is capacitor, there cannot be current because this has been fully charged. So no current can flow through the capacitor. So there is no current in this branch. So whatever current will flow like this. I. So let us find the current. To find the current, let us find the total resistance of the circuit in steady state. Okay. So total resistance will be how much? The current is flowing like this. Remember, this is useless. The current will not flow here. Okay. In steady state means no current flows through the capacitor, and therefore, if current cannot be here, it cannot be here also. No. So no current can be in this branch. Basically, this capacitor acts like open circuit once it is steady state. So current will flow only in this circuit, in this part of the circuit. So total resistance felt by the current will be what? This 1 ohm and this 0.5. So total will be 1 ohm plus 0.5. 1.5 ohm. So current will be applied voltage divided by total resistance. What is the applied voltage? 3. And total resistance is 1.5. It is 30 by 15. So 2 ampere. So 2 ampere current is flowing here. Okay. Now they want charge on the capacitor. For that we need voltage here. Now you please understand, there will be no voltage here. Why there will be no voltage here? Because no current. So voltage here is 0. Now can't I find voltage here easily? Because I know current flowing in this resistor. Yes or no? So if I call this point A, this point B, what will be potential difference between A and B? You know the current, how much? 2 ampere. And what is the resistance in between A and B? 1 ohm, R2. So 2 into this resistance 1, which is 2 volt. Now once you know the voltage here, that voltage usually will be divided here and here. V will be V1 plus V2, but there is no voltage here, remember, because there is no current in this branch. So this voltage will be also voltage here, remember. So voltage here will be same as voltage here because no voltage is in this resistor. So potential difference across capacitor will be same as 2 volt. Okay. The reason is simple. There is no current flowing here, so there cannot be any potential difference, right? So this point and this point, this point, this point, this point, this point, this point, till here the potential will be same, and this point and this point also potential is same. So usually we write this voltage will be V1 plus V2, but here V2 is 0, so this voltage will be here. So once you know potential difference for capacitor, what will be charge? C into V. What is capacitance of this capacitor? They told capacitance of this capacitor is 1 microfarad and voltage is 2 volt. So answer will be 2 microcoulomb. Okay students, so option B. Remaining questions we will be doing in the next session. So next Thursday again I will make a similar video containing more JEE questions. So too many questions we have discussed already for today. So this much should give you confidence to solve the assignment sheet which I have given, and therefore you can perform better in your PTE. Okay, see you.